Popular Joseph, the physics enthusiast. So today we are going to be doing spherical mirrors, and then we'll consider positions of images for object placed at different positions on the principal axis. Stay with me as we do this together. We're going to be considering for objects before C. That's before center of curvature. So the first thing we will do is to draw a straight line. Okay, so a straight line is known as the principal axis. So this is my straight line. Okay, so we are going to share this line. Let me turn my ruler to centimeter. You share it into the same centimeter. So let me use 4 centimeter. Okay, from this end. So this is 1, 2, 3. Let me use 3 centimeter instead to save space. 1, 2, 3. Okay, so this is it. So on this first, I'm going to draw using a curve. I'm going to draw a curve on this end. Okay, using a protractor. So this is going to be my mirror. We'll put the silver lining so it looks like a mirror. After I've done this, I label it CFP. So this is center of curvature, this is the principal focus, and this is the pole. So now we want to consider for objects before C. So if the object is before C, it means I'm going to be drawing my object somewhere before C. This is before C. Okay, so you just draw a straight line like this on the principal focus with an arrow head. So this is my object, so I label it object. Okay, so now there are 2 principles, or rather 3 principles. Any ray that is parallel to the principal axis would, after reflection, pass through the principal focus. Okay, so I'm going to be drawing a parallel ray. Okay, so we have this. So this is a parallel ray to the principal axis. So after reflection, according to the rule, it is expected to pass through the principal focus. This is the principal focus, so we'll make this ray to pass through the principal focus. So we have this, right? So the next rule we are going to be using is the rule that the ray will pass through the principal focus. Any ray passing through the principal focus from the object would, after reflection, be parallel to the principal axis. So the next thing is the ray will pass through the principal focus. So this is the principal focus. So we are going to connect this point and these points together. So if we do this, we have this. You can see it's passing through the principal focus. We'll do our arrowhead. Then after reflection, it will be parallel. So we have this. After reflection, it will be parallel. So this is this. So you can see. So we'll draw our arrowhead here. Okay. So now you can see this is the point of intersection. This point where the 2 lines are meeting, or the 2 rays are meeting. The point of intersection is where the image is formed. So we are going to draw this line. So this is where the image is formed. So now what can we say about the characteristics? Okay, now the characteristics is that the image, you can see that is smaller than the object. The image is smaller than the object. Let's measure. Let me even measure it. Let me measure my object. My object is 1 point. Let me measure it like this. My object is 1.15. Let me measure the image. So the image is let's see, it's not up to 1. I think it's 0.8. So what does this mean? It means that the image is reduced, is diminished. Okay, if you compare the image to the object, it is smaller. Okay, So it means that one of the characteristics for this is that the image is diminished. Another word for diminished is that it's reduced. It is smaller than the object. So the image is diminished, or you say it's reduced, or it is smaller. So the image is smaller than the object. Then another thing is that the image is formed between C and F. The image is formed between what? Between C and F. Permit me to use abbreviation. C is center of curvature. So the image is formed between center of curvature and principal focus. What is the third characteristic? The third characteristic is that the image is inverted. What does it mean to be inverted? It means, look at the object, the image is upside down. While the object is facing the other direction, this one is upside down. So it is inverted. Rule number 4, what does it mean? It means that the image is real. Image is, it is what? It is real. Because it is formed on the same side as the object. So it is real. Okay? So if the image were to be formed at the back of the mirror, then it is not real. Okay? Now, number 5. What is the fifth characteristic? It is, I think that's all. What else can we see? That's all. So let's do for object. We have done for object before C. Now let's do for object at C. Let's do for object at C. How many minutes? Okay. So object at if the object is at C, the same rule. We are going to draw the principal focus. So we'll draw the principal focus, which is a straight line. Okay, so we'll use 3 centimeters like we did before. We share this is this 1, 2, 3. Make sure you are using 3 centimeters all through. 1, 2, 3. So 1, 2, 3. Okay, so I use my protractor to make my spherical mirror. At that point, I have marked for 3 centimeters. You can see the point here. Okay, so make sure you have it on the point. So we have this. So shade it so it represents a proper mirror. So if I do this, I label next CFP. C for center of curvature, F for principal focus, and P for pole. Sorry, I missed it. My pole is supposed to be here, and then the principal focus is here, then C is here. CFP. Pardon me, please. So I said the object is going to be at C. So for object at C, this is where we mark 3 centimeters. Okay, we have this. Object is going to be at C this time. Okay. So we are going to draw a parallel ray. Okay, parallel ray to the principal axis. This is what we are drawing. We'll draw a parallel ray to the principal axis. Then you put your arrowhead. Of course, you know that principle. Any ray that is parallel to the principal axis would, after reflection, pass through the principal focus. So we'll have this now. So we're going to connect this point and this point. So if we connect this point and this point, okay, we'll have this. Okay, so this is this, right? So now the next one is to draw a ray passing through the principal focus. Any ray passing through the principal focus would, after reflection, be parallel to the principal axis. So we're going to be connecting this point and this point. Okay, we'll connect this point and this point from the object to the principal focus to the mirror. These 3 points down. We put our arrowhead. So now it's after reflection, this ray is expected by law to be reflected parallel to the principal axis. So this is it. So we have this. So we have this. So this is a reflection. The arrow will be like this. So we can see that this is where the image is formed. Okay, it is formed here. The image is formed here.